we have question 34, and here the programmer is deciding to use a list of integer objects, capital I, which is implemented as array list to store numbers, right? So we have this class caller. It has an an instance field called numbers that is a list that contains integer objects. We have the driver, which runs getList and shuffle. Right? GetList is here, and it returns a list that has numbers from 0 to 90 in order. So at this moment here, numbers is equal to a list that contains integer objects that contain the data 0 to 90 in order. Runs shuffle. Shuffle shuffles the numbers up, and we're done with the constructor. Right? So after creating a caller object, what you have is a array list, or a list of integer objects from 0 to 90 that are shuffled. Right? And so these options here are a bit confusing to nail down an answer to, unless you go ahead and code it. So I went ahead and coded it. Okay. And what the question is asking is, when the programmer tests the constructor of the caller class, she gets a null pointer exception. Right? What could be the cause of this error, and what is null pointer exception? Maybe I can bring it up here. Java null pointer exception. So what is it? It's thrown when an application attempts to use null in a case where an object is required, right? So this is like calling the instance method of a null object, right? You can't call a method on a null object because there is no method attached to that null object. Accessing or modifying the field in a null object, so you say null.xnum is equal to 7, right? Well, null doesn't have an xnum, so you can't do that. Taking the length of a null, right, as if it were an array, so you have a arr is equal to null, and you do arr dot length, right? That would break out with a null pointer exception. So yeah, modifying slots of an array that are set to null. So if you have like an array of size 10 and you're trying to access the element in index 10, there is no index 10, right, because it goes from 0 to 9, and you're trying to like take that value and add 5 to it, well, that's going to break out with a null exception, null pointer exception. And this I don't think is in the AP subset, so we'll just ignore that. And so, right, those are the different possibilities of how that can possibly get thrown. And option A is saying that the caller object in the driver class was not created with the keyword new. So I'm over here. I'm going to take away the new keyword. I'm going to compile. And what does it do? It does not, well, I mean, the important part is it does not throw a null pointer exception. Kyle, we gotta get going. So it does not throw a null pointer exception, right? So what does it do? It's looking for a method called caller, right? So this capital C here is just convention, right? It's just like what we should do, but it's not what we have to do, right? This is the same to the compiler. Capital C is the same as lowercase c, but we do capital as programmers to be more clear, so that we can say, hey, this is a class name. Right. So what it's looking for here is it's saying, okay, my C variable that is type caller is going to be equal to the return value of this method called caller, capital C, right? But there is no method called caller, so it breaks out an error. But if we did have a public static caller method, right, that returned a new caller, this would be valid, right? Because right here it would come up here and run caller, and then caller would return a new caller object, and C would be equal to the new caller object, right? I compile, no errors. So that's what is happening here, right? No new keyword. It's looking for a method called caller. It doesn't find it, errors out. So A is not the cause of the null pointer exception. So I'm going to put the new back in here. And then part 2, B, is programmer forgot to the return statement in getList that returns a list of integers. So I'm over here in getList. So I programmed this, and we have the instance field, and the constructor is defined, right? And we have getList, which generates a list by adding the I variable to the list, right? And also packaging it up as an integer, right? So we're creating a new integer object that has the value 0, then 1, 2, 3, 4, 5, and we're adding it into temp num, and then we return temp num right to here, and numbers is equal to temp num. So after this line of code is executed, numbers is a list of 0 to 90. And then we run shuffle numbers, and what does that do? It basically swaps out, right? So what am I doing is we have I is equal to 0. That's the 0 element in the array list. We have random, right? Generates a random number that's limited by the size of the array list. And then I am grabbing the random element, saving it, setting the random element to 0, right? The 0 element, the I element. And then I'm taking that random that I saved in temp and I'm setting it to the 0. So I'm swapping out 0 and the random. The next iteration it would swap out 1 and the random. Next iteration it would swap out the 2 and the random. And at the end we'd have a shuffled list, right? And then we have our toString, concatenates onto S and then prints out S. So so part 2 is saying that getList does not have a return statement, right? So right here. And what would happen if getList doesn't have a return statement? Well, then this getList would return null, right? Numbers would be equal to null. Shuffle numbers would run a for loop on size, but size of null is would break, right? With a null pointer exception, right? So that's what they want you to think. Okay, but that's not what actually happens. So let's go ahead and delete that, compile, and that's what happens, right? Missing return statement. Why? Because we listed here that getList is going to return a object of type list, right? So since we don't have that, the compiler stops the running of the program before it tries to run, right? This is compile time error, which happens before the running of the program. So that's what happens, right? And if this was void here and we didn't have that, then we'd have a null pointer exception right there when it runs size, right? So B is not the right answer, right? B results in a compile time error. And then we have C, the declaration of numbers is incorrect and needs to be equal to null. Well, that's not really true, right? Because here when we're defining our instance fields, we never initialize them. We never say equal to something, right? That the equal to something, the initializing is done in the constructor, right? And if you think about it, when we do this, what is numbers equal to at this moment, right? Right after line 5. Well, numbers is equal to null, okay? Like if we say like caller C, right? Well, what's C equal to? Well, it's equal to null, right? So that is incorrect, and I can prove that by running it. Oh, I'm sorry, over here, running it. And we get our numbers that are our list of 0 to 90 and shuffled, right? Printed out here. Okay, so that's not true. And then D, the getList method was an attempt to was made to add an integer to the array list that had not been created with the keyword new. So here we're in getList, and they're saying that we try to add an integer without the keyword new. Okay, so I take that out. And I am compiling. What does it give me? It says can't find the method integer, right? So this is the same idea as taking out the new over here in caller, right? If you take out the word new, keyword new, then it's going to look for a method called capital C caller, because capital C is nothing special, right? If it was something special, then we could just do that, and then the compiler would say, okay, it's capital, it must be an object. Let's look for that class, okay? But it's not. It's just programmer convention. So over here, it's saying, okay, I'm going to add the return value of a method called integer that takes in an integer, right? And that's a compile time error. So D is not true. Okay. And another thing that I also want to mention is right here, we don't even need the keyword. We don't even need to say new integer I. Okay, when we're adding to the array list, we could just say I. Okay, and you're thinking, what, huh? Right? I is an int. I is a primitive data type, and we're adding it into an array list. Array list can only contain objects. This should not work. And you're right, it should not work. The reason why it works is because of something called auto boxing. All right, and autoboxing was introduced in Java 5 and later. And what is autoboxing? It's when you're adding primitive data types into arrays or into variables of type, like for instance, we say integer I is equal to 5, right? 5 is autoboxed into the variable I, right? It's automatically wrapped into a integer object and put into the variable I. So this is the same as saying new integer 5. Okay, just like up here is the same as saying new integer I. Okay, autoboxing, right? Happens automatically. This is to make life easier for the programmer. Okay, so D is not the correct answer. Right, and then we get to E. Shuffle numbers algorithm went out of range, causing a null integer to be shuffled into the array list. All right, so let's just assume, like down here in the shuffles, that it somehow went out of range, right? And somehow a null value got shuffled into the array list. So maybe we could set temp. Maybe we could set this to null right here. Okay. So then this is like simulating what this option E is saying, right? That were some null values, right? Or a null value. Okay, so here we have the list. It has some null values in it, right? But that doesn't cause a null pointer exception, because shuffle is just shuffling them. It's just shuffling them, right? So after running shuffle numbers, what E is saying is that one null value was put into the array list. Okay, so what, right? If we had here like a for loop that went through each object, right, and we said object dot, and then we ran some method, then it would bust out with a null pointer exception, right? Because one of the objects in the array list would be null, and then it would be null dot method, right? Trying to run a method on a null piece of data, and that would break out with a null pointer exception, but not the way that the constructor is set up at the moment. Okay, so none of these. That's my final analysis. I might be wrong, but I'm pretty sure I'm right.